Okay, let's have a look at this question. First part, let's see what's going on here. Circle with that center and pass through that point. What's the equation of the circle? Well, we know the center, we just need to get the radius. So the radius is the square root of 8 squared plus, oh, that's 15 squared, isn't it? Which is 225. Now, is this going to be anything nice? Let's see. 225. So that's the square root of 982. Nope. I'll have to check on my calculator if there is a square root. A convenient square root of 289. Let's see. Root 289 is 17. Okay. So that will be x plus 3 squared plus y minus 7 squared equals 17 squared. Alright, that's the first part. The equation of that circle and that line intersect at P and Q. Find where they meet. So this is a simultaneous, and this question is begging out for you to take x as 3y minus 25 and to sub that in here. So x plus 1 would be 3y minus 24 squared plus y minus 8 squared equals 160. So that would be 9y squared minus 144y plus 576 plus y squared minus 16y plus 64 equals 160. So that's 10y squared minus 144, 150, 160y. It'd be really nice if those numbers added up nicely as well. 576 plus 64 minus 160. Well, that's great because that's plus 480 equals 0. So I can get rid of, I can divide by 10. So what could it be? 12 and 4. Y minus 12 and y minus 4 equals 0. So y is 12 or y is 4 and x is 3y minus 25. So 3 times 12 minus 25, that's 11. And then 3 times 4 minus 25, that's minus 13. So there are the two intersection points. Check if PQ is the diameter. Well, if it's the diameter, then it should equal twice the radius. So the distance here will be the square root. The difference between 11 and minus 13 squared is 576. And 12 and 4 is 8 plus 64. So that's equal to 8 root 10, which is equal to twice 4 root 10. Oh, and by the way, 4 root 10 is root 160 to root 160. So the answer is yes. It's the diameter, which is good because it'd be kind of weird if they asked you to check if it's the diameter and it wasn't. So this is all positive signs that everything is going fine for this question. And then the C part, the final part, we have that circle passing through those 2 points, and that is a tangent at the point 3, 3. So it means I can form 3 equations with 3 unknowns. So if we put in the first one, 3, 3, we have 3 squared plus 3 squared plus 6g plus 6f plus c equals 0. So in other words, 6g plus 6f plus c equals minus 18. That's equation 1. And then we put in 4, 1. So that would be 4 squared is 16 plus 1 is 17. So you have 2g, so that would be 2gx, sorry, so that's 8g plus 2f plus c equals minus 17. That's equation 2. And then sub 3 that doesn't quite make a nice equation. That last one, does it? So let's just have a quick sketch here. We have the circle, but basically we have no idea about the F, G, and C. We have 2 points on it, and actually we know that one of them's a tangent there. So there's some point here that will make this the same distance. I don't really want to use the perpendicular distance formula. I feel like that's making it more complicated. Let me think for a second. Okay, I have an idea. Let's try and just sketch this out a little bit more accurately. So if I just do a rough XY axis here. X, Y. So we're at 1, 2, 3, 1, 2, 3, 3, 3, and then 4, 1. And there's a circle here. Whoops. Well, this point here is a tangent line at the point 3, 3, and that's the point 4, 1. So actually maybe I shouldn't quite draw it that steep, though it might get a bit confusing. I'll draw it a little less steep. Okay, and that's at the point 3, 3, and that's at the point 4, 1. And I mean, I don't know how to best draw this circle, something like that. So we know that this line is y equals 3x minus 6. So that means I know the slope at this line here. This has a slope of minus 1 over 3. Meaning every time I go out 1 unit, I mean to say, sorry, when I go out, it's rise over run. So every time I go out 3 units, I go down 1 unit. I know it doesn't look like that on my scale. So it's like this. I go out 3 units and I go down 1 unit. That's what this slope, minus 1 over 3. Rise over run, 1 over 3. And I'm starting at the point 3, 3. So this line here, a point on this line would be in the form 3 plus 3t, and then 3 minus 1t. So every point on that line would be of this form. So when t is 0, you're at this point here, 3, 3. And then t is 1, it means you come out 3 units and go down 1. So that'd be 6, 2, etc. And I have to land somewhere on this line. So the distance here and the distance here, they're equal. So the distance from there to 3, 3 and from there to 4, 1, that has to be equal. Which means the squares of the distance have to be equal as well. So let's just call that point A, that point B, and that C. So we are saying that the distance A to C has to equal the distance B to C. Okay, so 3 minus that, 3, so that'll be minus 3t, so that's 9t squared. And then 3 minus that would be plus t squared, so that's the first one, equals, and then 4 minus that, 4 minus 3 is 1, so that's 1 minus 3t squared, and then 1 minus 2 plus t, I hope. Now I could easily have made a mistake there, so let's just double check that. 3 minus that leaves you with minus 3t squared is 9t squared. 3 minus that leaves you with t, which is squared. 4 minus that leaves you with 1 minus 3t, and 1 minus that, 1 minus 3 is minus 2 plus t. Yeah, squared. Okay, this doesn't look too bad to solve. So that's 10t squared equals 1 minus 6t plus 9t squared plus 4 minus 4t plus t squared. That's good because it's not quadratic. 9 and 1 makes 10, which cancels with that. So taking the t's to the left, I get 10t equals 5. So that means t is a half then. So therefore, the center, I can make some space by just deleting this. It's not even a full rise over run in my triangle. It's only half of one. 60, 40, 10t. Yeah. So the center is at 3, so 4.9 over 2, and then 3 minus after 5 over 2. Let's just double check that. 3 plus 1.5, yeah, 9 over 2. 3 minus 0.5, yeah, 5 over 2. And the radius I can work out by using one of the distance formulas, like this is the AC one. So the radius would be the square root of 9, and the t was a half squared plus a half squared. So let's see what that is. 9 over 4 plus 1 over 4, 5 over 2. So it's root 10 over 2. So it's a little bit messier than I thought, but the equation I'm getting for the circle is x minus 9 over 2 squared plus y minus 5 over 2 squared equals 5 over 2. That's what I'm getting. Okay, that's correct. So now let's have a look at the last part. Find the coordinates of the point on the circle at which the tangent parallel to that touches the circle. Okay, well, I'll need to make a bit of room, so let me just delete this work in here. Okay, so we have our circle now. We know the equation, the center, the radius, everything. Find the coordinates of the point on the circle at which the tangent parallel to 3x minus y minus 6 touches the circle. I'm not quite sure what that means. Find the coordinates of the point on the circle at which the tangent, at that point I assume, at which the tangent parallel to 3x. Okay, hang on. Wait, that's a tangent there, 3, 3. Okay. So find the coordinates of the point on the circle at which the tangent parallel to 3x minus y minus 6 touches the circle. Oh, okay. So are they just looking for the opposite one on the other side? So I think we can do that with a translation. So 3 to the center, which is just as a decimal for the moment, 4.5 and 2.5. That's add 1.5 and minus 0.5. So if we continue that translation again to get on the opposite side, 4.5 plus 1.5 is 7, 2. So I think, if I understand it correctly, it would be, now of course 4.5 plus 1.5 is 6. How do I get through the whole question and then make a mistake like that at the very end? So 4.5 plus 1.5 is 6, not 7. Okay, so that's that question there. Let's wrap it up.